Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at Daily Leetcode Challenge, day 16 of the April 2024, and we have a very good question in front of us. This is the exact level of question that you can expect in the online assessment or in the coding interview of some of the big companies. Okay, especially in the coding interview, I can say that in online assessment the level will be slightly harder, and it will not be that easy to understand. As simple as that. So this the kind of things you can expect in a coding interview where the interview will be in front of you. You will have to explain them each and every step, and mostly this kind of question will be there because they are to the core of the algorithms or the data structures. Okay, as simple as that. It totally revolves around the topic of trees. We had many questions on trees for the last few days, and yesterday's question was also one of the good ones, where we are calculating the sum of the starting from root to the leaf. You can see that question as well. So from this particular month we have a lot of questions on trees. So if you have not done that, please do and give it a try, because you are missing a lot if you are not trying them. Okay, let me say it very clearly. Okay, now coming to this question, it's again a very good question, but it's very different from what we have seen till now. Okay, it involves a lot of other concepts as well. We'll see that now, but yeah, let's begin. So add one row to tree. The name of the question itself makes it very clear. We are going to add something to the tree. Okay, that's we are going to alter the data structure now. Okay, so what we are going to see the examples here. So what they are trying to say is, at this particular depth, okay, you'll have to add nodes of this particular value. Okay, so when I say depth, what it means, see, the root is at a depth of 1, okay, by default. So that's how the depth is calculated. If once we go down, the depth will keep adding. Okay, that means 4 is at depth 1, 2 and 6 are at depth 2, 3, 1 and 5 are at depth, okay, 3. As simple as that. So they are saying, like, whenever you are depth 2, okay, you'll have to introduce few new nodes, okay, which whose value is going to be of this particular value. And let's see how we are doing that. Okay, so see this example here. They are saying at depth of 2. Okay, that means, see, currently 2 and 6 are at depth of 2, right? So instead of them, we are going to introduce some new variables. Okay, some new nodes. How to do that? You'll see the exact thing now, but just try to understand what is happening. What we did, we introduced a node called with a value 1, okay, after 4, and whatever was the initial left subtree of 4 became the left subtree of this. Okay, the right subtree of this is nothing. Okay, similarly, whatever was the initial right subtree of 4 became a right subtree of this one. Okay, and for this one the left subtree is none. So I hope you have now got a gist of the question. So let us now see the question. Okay, given a root of a binary tree and two integers val and depth, add a row of nodes with value val at the end of depth. Okay, note the root is at depth of 1. So these are some of the rules. Okay, the last one is the edge case. We will code it separately, but let's see the first three basic conditions. Given an integer depth, for each not null tree node cur at the depth minus 1, create two tree nodes with value val as cur's left subtree root and right subtree root. Okay, that's what we have seen now. Okay, so at this particular depth we created two nodes. Okay, as simple as that. Now let's see the next one. Current's original left subtree would be the left subtree of the new left subtree root. Okay, in this case, as you can see, the subtree of 4 became the left subtree of 1. Okay, similarly, the right subtree of 4 became the right subtree of 1. Okay, that's what they're trying to say. Kurt's original right subtree should be the right subtree of the new right subtree root. Okay, now coming to this particular thing, remember this is going to be a base condition. If depth equal to 1, that means there is no new depth minus 1. That is, see, the root is going to be, see, you cannot go level up from root. Okay, as simple as that. So when we say depth of 1, that means the new element is going to be root itself. Okay, that's what it is. Then create a tree node with value val as the new root of the whole original tree, and the original tree is the new root's left subtree. Okay, so that's what we are trying to code here. Okay, now let's see the coding part. If the depth given is 1, that means we are going to introduce a new root. Okay, so this is how I'm creating a node. Okay, this I'm going to create a node. Okay, remember this is the class, so each node in this subtree, that is in this tree, is going to be object of this class. That's what we are going to do to create a new node. Okay, node is equal to tree node. Okay, what is tree node? Tree node is this. We are going to initiate its constructor to create this node. Okay, tree node of this. What is this? The value first, I'm going to pass the value of val. What is val? Val is given to me in the question itself. Okay, next, it's left. See, remember depth is 1, right? It's going to be root. So as they have mentioned, the original tree will be its left subtree. Okay, I hope you have got that part now. Okay, original tree is left subtree. Okay, so the original root will now be a left subtree of it. Okay, that is, the new node will be pointing, there is no node's left pointer will be pointing towards the original root, and its right node will be pointing, that is, the right pointer will be pointing towards none. then we'll return this node. Okay, remember this is only true for depth equal to 1. In all other cases, I'm going to do a DFS traversal. Okay, and then we will be adding those two yeah, nodes. Okay, so this is the function call. I'm calling this on my root with level as 1. Okay, remember, depth or level both means the same thing, both are interchangeably used. It's not something which I am defining. It's already, if you are aware of these topics, level is also one of the terms which define the depth. Okay, right. Now let's see what it is. Non-local, I've already explained many times in my video. And whenever Python, you're going inside a function scope, always declare the things which you're going to use in the function, but which are not declared in the function already. Okay, that means, see, in this case, depth and val are not declared within the function, but I'm using it, so I'll have to call them as non-local. Okay, as simple as that. This is going to be one of the base conditions. If the root is none, simply return it. Okay. Now this is where I'm going to add those nodes. Okay, but let us leave for that. Now what we're doing, it's a simple dfs function. Okay, depth first traversal. Okay, you can see that. Okay, what I'm doing r dot left and I'm doing level plus 1. Similarly, r dot right, level plus 1. Okay, so when I realize that I am at level of depth minus 1, that is the level, I have to add two new nodes. One, as you can see here, if you understand this image, you can understand my code as well. Okay, so we'll see that and compare it on do. Okay, so what I'm doing, I'm creating a new node called node 1. Okay, I'm creating new node called node 1. Okay, what is the value? It's going to be a val. Okay, as you can see, the first parameter is going to be the value. What is the next parameter? Next parameter is going to be where its left pointer will be pointing to. So its left pointer should be pointing to left subtree of the original root. Okay, so its left pointer should be pointing to left subtree of the original root. That's what I'm doing here. Its right pointer should be pointing to none. That's what I'm doing here. Okay, once that is done, okay, make the left of the original root point towards the node 1. As simple as that. Similarly, for node 2, what I'm doing, I'm creating a new node using the constructor of the tree-node class. First parameter is going to be the value, as you can see here. Okay, as you can see here, the next parameter is going to be the where this left pointer should be pointing to. See, in this case, as you can see here, the left pointer is not pointing to anything. Okay, so in this case, the left pointer should point to none. Similarly, the right pointer should point to the right subtree of the original root. Okay, that is this part, the right subtree of the original part. So I'm doing r dot right. Okay, once this is defined, I will make the right pointer of the original root towards node 2. Once this is done, okay, I will be simply returning it. Okay, because remember, last time we returned node, but this time we will not return anything. Okay, why I'm not returning anything? Because remember, this became the root, so I have to return the root. But in this case, this is not becoming the root, this is another root. Okay, so that root, the original root, should be returned, because these things are added in the structure of the root. Okay, that is, in the tree where root is the topmost element, in that particular structure we're adding these new elements, but we'll be returning from the root itself. Okay, as simple as that. So this is going to be the function call. I'm calling this function from the original root, and I'm passing the initial level as 1. You can also write as like this, level is equal to 1. So if nothing is passed, it will take the level as 1. And finally, I'm returning the original root. Let me quickly run this and show you. I've already submitted this, by the way. As you can see, I've already solved this here. Okay, as you can see, this accepting all the test cases for, yeah, both the test cases, getting accepted. So this was my solution. What I'm doing here, see, there are first of all two things. One is the edge case, okay, where the root itself is getting a new, okay, replaced. Okay, that is the first case, and the original tree will become a left subtree of the new root that we have defined. Next, what I'm doing, I'm doing a DFS to reach a depth of is equal to depth minus 1. To reach this particular depth, I'm using DFS. Once this depth is reached, okay, I am creating two new nodes and pointing them as they have mentioned here. Okay, as they have mentioned here, I'm doing that, and then I'm stopping the DFS further. I'm not doing any DFS further. Okay, I'm stopping that, as simple as that. Once I've done that, I will, so this is the function call, and once I'm come out of this function call, I will return the original root which is given to me. Okay, this original root, I'm returning it. So I've already done this for you. Let me do it again. So yeah, it gets accepted. Okay, so you can see the other examples as well. It's more or less the same thing. Okay, the idea is very, very simple. The left subtree of the original root will become the left subtree of the new node, and the right subtree of the original root will become the right subtree of the new node. So often that was all for today. These kind of questions are really good, but remember one thing. See, because I was knowing this thing very well, because this thing is used every tree questions of Leetcode, so I was able to code in a much easier way. But remember, when you are in an interview or when you are in online assessment, these things will be slightly new. They won't be called in the way this is. Okay. In that case, you will have to be very, very, sure of what you are doing. Okay. And remember how to create object of a class in Python. These things are also important. Okay. They are not related to the tree data structure, but they are also important, because if you don't know that, again, you will not be able to solve this question, because this question involves changing the data structure by creating a new nodes. So this is something which I wanted to draw your attention towards. So please be good in Python if you are, at least, if you're aiming to solve your DSA questions in Python in the real interview setup. So please be prepared for that, because see, Python looks easy, but there are some tricks involved. Okay, remember that always. It's not that fair and simple. Okay. Because if you are not sure what it is, because see, I've already explained this. If you don't declare variables in non-local part, the compiler may behave in a very abruptive way. Okay, let me make this thing very, very clear. Okay, if you're not seeing such a behavior in Leetcode, that doesn't mean it will not happen in any other environment or editor. Okay, it will definitely happen, because something which is not declared as a not non-local, it will be installed with a default value. Okay, whenever you are using it. So please be careful when you're doing that. So yeah, fun. That was all for today. If you have any questions, please do feel free to comment below. And the link of this question and the code will be there in the comment section and in the description of the video. So yeah, fun. That was all for today. If you like my efforts, please do consider subscribing to my channel. It really gives a lot of motivations to continue further. Thanks a lot. See you tomorrow.